All right, going to D1 mold and tool today is still in the air.
Tell me what to do. Show me how to feel under your control. Everything is real. So hit me. So hit me. So hit me. First a confession. With you, I feel a connection. With you, it's like an infection. I've been infected with an obsession. With you, never any tension. Nothing but love and affection. Enough of my case, so let's cut to the chase. Listen up, cause these are the directions.
This is Tony Dungan. He owns D1 Mold and Tool, and he's going to show us our shop.
All right, welcome to D1 Mold and Tool. Our primary function is design and build of die-cast dies and related tooling. Some plastic injection, but for the most part, we're die-cast dies. Been doing it for right around 30 years, and we hope you like our shop.
For those that don't know what die-cast or plastic injection is, basically a customer comes and wants a part mass-produced, usually thousands of parts, and Tony's the guy who makes it. And so this is your design area.
Yep.
So people send in their part, and you take it from here. And
Exactly. We also do some development of parts. Here's a project over here that
how's the C-frame going?
it's doing pretty good. We've got it. It's actually in their hands. We haven't heard back from them yet, have we?
Yeah.
Okay. The original version of the part is extremely heavy. It's a sand cast version. We're turning it into a die casting to take some weight out of the casting, increase part strength, and reduce some of the machining costs within the part.
Right now, Phillips Patterns is the one sand casting them.
So we'll take that part along with the machined version of the part and also the complete assembled part to develop an as-cast version solid that will remove much of the machining. We'll still be machining the casting, however we'll be machining much less stock, thus reducing the machining time in the casting.
Now it's been 2 years since I'm here, so you probably had some new machines since I've been here.
Yeah. Then we've got this one. This is a new 20,000 RPM spindle machine. It is a YCM NSD 102 AM, which is strictly a die mold type machine. We operate with magnets and lasers. If we
let's take a look.
Get a little closer here, you can see.
Do all your machines pretty much have the magnets now?
Yes, everything has magnets and lasers. He's actually 3D probing a part for initial setup, and it will locate the part to where we know where G54, G55, whatever we're locating.
Yeah. That's the magnet or the laser checker.
And we're on the magnet.
Yeah. Check out your EDM stations, because I personally think those are the coolest machines you have.
We actually have a new one ordered. We have another AQ60L machine on order.
Now, you explained this to me a year or 2 years ago, but let me see if I get this right. So there's some cavities in a mold that are too deep for an end mill to get into, so you actually use your CNC machines to make. Do you have any graphite pieces sitting out here?
Yep.
Wow, that's a pretty detailed one. Yeah. So,
EDM is used for areas that you cannot physically cut with an end mill.
Yeah, like these
in the die steel.
Really intricate pieces in here that you just can't get into. So these machines take one of these, and you, instead of using a CNC cutter, it actually burns with an arc into the metal. And not only that, but these machines calculate how much material is being taken off the graphite while it's cutting the steel too, correct?
Right.
Yeah. Now
And there's a certain amount of overburn that you have in there, so we've calculated in the overburn to get where we need to be for a finished product, and then the EDM machine will orbit as it's cutting to dial in and fine-tune the dimensions that you're looking for.
All right. What's next?
This is our 30,000 RPM graphite cutting machine.
So this is where all the
This is where the electrodes get machined. It has 6-inch evacuation hoses, and it really does a nice job containing all of the graphite where we don't have a messy shop.
Okay.
Thanks.
So that machine makes these,
Yep.
which go on that machine.
This is our in-house polishing department. We're drawing out the walls. Even though we cut it, we get a really good finish coming off of our CNC machines, but we still draw out the walls to make sure that the customer gets good pull and doesn't get any sticking or dragging.
How long does it take to usually finish? Say that.
It depends on the complexity of the part, but that's probably looking at 10 hours, somewhere around there. There's some cavities that are just out of polishing. They're ready to go.
So it's usually about 10 hours a day for each one.
Right.
So this is, all these machines are going to be doing the mold that you showed?
Yep. A lot of these are upfront machining mills, if you will. Our lead men work in these areas that are leading the jobs. They're in close proximity to the crane, so they can help out our younger guys with assembly, tear down, and putting together sub-assemblies, plumbing, those types of things.
So when the designs finally come out here, you actually have, you know, 1 or 2 guys that handle all the way through the process?
We actually have 5 that handle our jobs will come out in the blue folders here that you see, and then the lead men have control of these blue folders, and then they'll distribute work to.
So this is pretty much like
individuals.
Ferrari engines. That's how they do it. At Ferrari, just one guy does the entire process of building the entire thing.
Right.
Tony's talked to us about making mold bases. So that's just the big pieces that those go into.
These are the inserts that goes in the mold base.
Okay.
You know, man, I'll show you what that is.
All right. So got to talking, and this is Floyd. He's grinding a mold onto this machine because it just got back from heat treat. In case you didn't see it, it looks pretty rough, and that's just the process of heating up the steel, and it gets deformed and changes color. But he's about to throw it on this machine and grind it. So this is this rough then. Then you heat treat it. Is it case hardened or is it
They
full?
heat treated it. They got the steel that was soft.
Yeah.
Yeah, they milled everything up and left like 15,000 on everything. And then they send out the heat treat, harden it, and then brought it back, and then now they'll grind it flat and get everything flat, and then they'll take it back up to CNC and remill everything.
Okay.
Finish the outside and all the cavity work on the CNCs up there.
Do you know if it's is it a case harden that they do or a through harden all the way?
I don't know what kind of steel that is, but probably like an H13 or something, so it's hard all the way through.
Okay, yeah. The way heat treating works is you send out certain kinds of metals, not every kind of metal can be heat treated, and they run it up to a temperature, usually 800 degrees, anywhere up to, what does steel do? Is it 1,000 or do they just do 800 to 900?
It's thousands.
Yeah. Aluminum's lower, around 600 to 700, but there's 2 types, through hardening and then case hardening, and it sounds like what it is. Through hardening, which is what this mold has been done through, is the entire thing has been heated to a specific temperature, and then they don't quench through hardening, do they?
No.
No. And then case hardening is a similar process, but they heat it up and then they dip it in water or oil or any kind of other liquid. And that hardens just the outside, but leaves the inside kind of soft, and they're used for different applications. The reason for this process right here is because when these molds are heat treated, even though they look flat, they're actually warped by a couple thousandths, which is about a human's hair. And you can actually see it right now because if I can come around here, you can see how some of it's dirty looking and some of it's really clean. And And that's because, you know, even though it's only like a human's hair width, that it's wavy. And if you were to take this and not grind it and then throw it on a CNC machine, it would be flat, and then as the machine's cutting it, bad things can happen. So this is the process to get it ready and prepped for finishing the cuts.
The foundation to get started off of, and everything's squared up from there, you know.
Yeah. And in case you didn't catch it, this entire shop makes the molds that go on the machine that I was working on yesterday, and then that machine makes the castings, which you saw on the wall earlier.
So let me ask you, how do they make the sand casting?
So it starts, you know, just like here with a model, and then
So,
I can make a. Oh yeah.
I'll look. Say they was gonna make this flashlight, half of it.
Okay.
They just stick this in sand. I know this isn't good.
You can actually do it that way. Yeah. You could take, well, aluminum shrinks about 1/8 inch per foot, so it'll be smaller than that by a little bit. The way you would make something like this in green sand, which is what I do. You take a model, and then with this, it's so small that I could actually print this out of a 3D printer, just out of plastic.
Okay.
Super glue it on a wood board, run my gating, like my channels for this, and then you take that board, stick it in sand, and then you make a top half and a bottom half. You pull the top half off, you pull the board out, and then put the top half back on, and you've got a complete mold like this, and then you pour the metal into it, and then knock out the sand, and you have your casting.
So there's somebody doing this all day long?
Yeah, there's a guy, we've got an entire sand system. It's a 70-ton sand hopper that feeds the sand up, and then it goes up a conveyor belt, and they put moisture in it, and then it runs up on.
Special kind of sand. It's
green sand. It's actually a rock. Not bentonite. I can't remember the name of it right now, but it was originally sand. That's why it's called green sand, but it's actually a rock, and then it runs up into a conveyor belt, and the guys on the molding stations, they pull a lever, and it drops sand into the box of the mold, and you make the mold, and then pick up the mold, and you spin around, and you put it on a pallet, roll it across the deck, and then the deck guys dip their ladles in the metal, and then lift it, and then pour it by hand. Yeah, and that's what that video showcases.
Why do they do this process for on pouring it like that?
Instead of doing like this or money, I can make a pattern for a couple $100.
Okay, that's what they call a pattern.
Yeah.
Okay.
Yeah, pattern maker. My technical term of what I am is a pattern maker.
I got you. Okay, see, I didn't ever understand that. I thought Phillips pattern was just.
No, it's actually a pattern. It was originally a pattern shop with my grandpa back in '47 in his chicken coop. Wow. He quit his job as a pattern maker and bought some machines, which back then was just, you know, like hand mills and stuff. Yeah. And he would make them out of mahogany, and that's how it started. Most of the patterns were all done by hand, and then, you know, as CNCs got more advanced in the 60s and 70s, then CNCs were originally the tape feed. You probably around them. Yeah, and that's how they would program it, and then finally 3D system or 3D design came along, and then CAM came along, and now it's all done by computer. And now they have printers you can buy for $1,000 in your house, and you can make a pattern. And that's what I really want to get into with making money, and you know, that's going to be a very popular thing for the people watching my videos.
That would be something the average guy could afford.
Yes. Yeah. So there's a lot to it.
Yeah, I realize that. Okay, I'm gonna shut this thing off.
You done for the day?
Yes, sir.
Okay. What'd you get to? Was it 5,000?
Yeah, I just took 5,000 off, but you hear it, see it's wearing the wheel down.
Oh, so that's wear?
Yeah.
How long? You get about one?
I could probably take 10 thousandths off there rough, but
yeah.
You know, I'd redress the wheel and take a couple thousandths off to call it finished, you know. Tony, I'm a movie star now. You got to start paying me more.
Okay.
You heading out?
That Ferrari's on its way.
I like that.
About 10, 15 minutes.
That's a day.
Okay. Well, thanks for letting me
nice
video.
to meet you, man.
You too.
Tell Greg I said hi.
Yeah. Nice guy. I like sitting and talking to people about like how they got where they are and, you know, what they do, where they came from. I think that's the most interesting thing for doing this. And so this shop is a tool and die shop, which makes the molds that go onto the machine I was working on yesterday. And that machine makes the castings that you saw on that wall right there. And this this company and the molds that these things make, they run hundreds of thousands of parts. Like, this is how your iPhone case was made. Die and mold shops are pretty much the blacksmiths of today. Anything you own probably at some point was touched by the guys that work in shops like this. You know, and you never see this in like shows like how it's made or how stuff works. You know, they just gloss over how things are, you know, assembled, but they don't really show the in-depth processes of how shit's made. And hopefully that I'll be able to do that. You know, I'm not making any money right now. I'm surviving on money that I have saved up. And not having a paycheck every day is very stressful. So hopefully this works out, and you know, hopefully people are interested in this stuff. But we'll see. You know, the only way to find out is to try it, see what happens. Okay, it is like 5:30, 6 o'clock, Friday night. I've got still 700 gigs of footage to go over and edit and get 4 or 5 days worth of stuff up. So it's time to go home and edit video all day, and then tomorrow, and then the next day. And then hopefully I'll be catched up. And then next week, we are gonna be going down to Indy for an aluminum and brass foundry, which the owner has designed an LSX engine. And if you don't know what that is, this is what an LSX engine is. And we're going to be talking with him and Pat McQuarrie, if he comes, who owns Nye Automotive in Muncie and does tractor pull engines, like 3,000, 4,000 horsepower engines, insanely powerful. And on top of that, with Greg Hazley from Cam Tool, who is going to be doing the rotors for our 671 blower, and we're going to be talking about hopefully doing a turnkey blown LSX engine. Hopefully, I mean, it's still talk. Don't hold me to it. But hopefully that'll be next week, which also I have to get into Pat Nye's shop to show you what he does, and Greg Hazley at Cam Tool's shop, so you can kind of get what he does. So that's next week.